Part 4, the last and final part of the lecture series on running water/rivers. Okay, so what happens in an old river valley that I've referred to but didn't show you yet? When the water comes down, as we talked about, the fastest water is on the outside of the curve. This is important if you're kayaking. You may think you want to cut across this side, you're going to be in slower water. It's weird. This is going to be cut away over time. This is going to be cut away over time. And this cut bank will be cut away over time. Eventually, this neck becomes incised or cut away, and you're left with an oxbow lake, again, like the big bow that goes over the neck of the ox in the farm. And then the river continues this way. This happens only where a river is depositing a lot. But does this really happen? Yeah. Here is the Oxbow River, which has been abandoned. And as I showed you earlier, here's some old farm areas, I believe in Mississippi, you may be able to see on the print. Let's see if this works.
Flowing slowly now across its floodplain, our river bends in loops and lazy curves called meanders. It's now cutting more sideways into the land rather than downwards. At the same time, it's dropping the silt, sand and stones it's been carrying. Meanders are an important feature of all rivers, large or small. They are formed as the river swings round bends, forcing water to flow faster on the outside of the curve, cutting into the bank. This is called erosion. Meanwhile, water on the inside of the curve is slowed down, making the river drop its load. This is called deposition. In a meander, erosion and deposition are happening at the same time. At this point, the river is eroding into opposite banks. Eventually, it'll cut through, changing its course and leaving the loop of the meander behind as an isolated oxbow lake.
That's good. Here's another satellite image. All this stuff is old meander. Pretty cool. Forget where I got this picture, but again, also very cool. Notice you're not in the mountains anymore. This is an old river. Okay, I got it. Old rivers slow down and drop their load, blocking their own path, creating meanders. They are no longer erosional, no longer digging valleys or canyons. They deposit instead. You know, this would sound a lot better if I had a British accent like that guy. Young rivers, in contrast, have canyons, valleys, high velocities, are straight, and erode downward. Old rivers have meanders, deposit their load, are slow, and have really wide valleys. So, old rivers meander, and young rivers have canyons. Got that? Old rivers wiggle and have wide, flat valleys. Young rivers, walls. Okay. How do you get a meander in a canyon? How can that possibly happen? Let's see what it looks like from above. This is the goosenecks of the San Juan. Some of you may have been here. Here's a little parking lot, and you can look out on this area. This is the San Juan River flowing this direction. Here's another view of it. So what happened here? At one time, long ago, before even I was a kid, there was a river at base level. It was meandering. Little by little, the land was lifted up so slowly that the river stayed in its course, excuse me, but eroded downwards to create incised or entrenched meanders. This is something that's very rare around the world, but you see it frequently in the southwest. This is the Escalante, which is spelled badly, river in Utah, and these are old entrenched meanders. Now let's talk about floods, and hopefully we'll get through this in the next few minutes. This is what happens in a flood. If water escapes its bank, you're in trouble. Is it only back east? No, this is, as I was talking about a while ago, Bell Road, and here's 115th Avenue. This is the Awafia Riverbed, and people have built right next to the riverbed, and they're threatening to build down in the terrace area. It's kind of crazy. Oh well. I'm not sure why I stuck that in there. You don't need it. Ignore that. Pay no attention to that graphic. Here's a house with running water. And this wasn't a Hurricane Sandy type event. This was a river event. Here's a picture of the house at one point, and a few days later, here it is. Here's a lady drilling into rock to stick sensors in to see what's going on with the runoff. Now, something that's interesting, as we urbanize an area, as we build streets and houses, this is what normally happens after a rain. When we cover a lot of the ground, we increase the likelihood of flood. Because the water can no longer soak into the ground, it has to run off, and it does so very quickly. As Phoenix has grown, we've seen more and more floods. By the way, this is the same picture. House. House. And this looks like Hawaii, but I'm not sure. Don't build near the flood level. You don't need that. In order to control floods, we in Arizona and a lot of other places have built reservoirs. Typically when you get rainfall up in your drainage basin, it will all zoom through here and start flooding down below. Well, what we do is create a dam that will hold the flood water and let it out little by little. Why is this good? Farmers and people down below can rely on a consistent supply of water, and we can use these to create pollution-free energy. There are costs. You change the nature of the life both down the river and up the river, and each dam has a limited lifespan as sediments coming down here reach their base load and get deposited. Back in the 1960s, I think it was, there was a big flood in this area of the Big Thompson Creek. Several people killed, lots of things washed away, and we really don't need to know about that. Fluvial processes. Fluvial means things that flow. Here we are on Mars. This is one of the old explorers. Here's evidence of old flowing material on Mars. And then here are just some pictures I threw in just for the heck of it. Okay, deltas and alluvial fans, an important concept. As we talked about at the very beginning of the lecture, a long time ago, this is where the Mississippi River flows into the Gulf of Mexico. These used to be barrier islands, but as you can see, they've been cut or incised by pipes going out to oil rigs and the like. That means these go away, which means this land goes away, which means this land gets flooded. We could have done it differently, but we didn't. This was the cheap way to do it, and we're paying for it. This is a typical delta, where the water runs into a larger body of water, and the sediments get dropped when the water slows down. Again, you won't find boulders. You'll find only some suspended load, probably not much bed load except during flood time. This is the Mekong Delta, I believe in Vietnam. Good area out here for fishing, but not for much anything else. Here's a typical delta formation. It's almost like sand dunes being formed. And these areas are important to maintain, which we are learning. Here is the Nile Delta, the Nile River flowing north out of Egypt. And yes, I have been here. Giza is somewhere in here, and I've wandered around there. Oh, this is is it the Irrawaddy? I forget. But delta after delta. All this is old delta. Lake Pontchartrain used to be part of the ocean area. Now we have New Orleans there. This is a delta near Arizona. This is where the Colorado River used to run into the Gulf of California. And this is the old sand that used to go down there. Do we see a face peeking through there? It looks like an eye. That's so weird. Ooh, creepy. Now, what happens if instead of the water running into an ocean, it just runs out into a flat area? You get what's called an alluvial fan. Again, it's kind of, well, delta shaped like a triangle. Kind of. This is in Death Valley. It tends to be a little steeper. It tends to have really large things. That almost looks like a foot. I'm seeing things today. And you get braided streams or distributaries and alluvial fans. They typically come from a narrow canyon. Here is a huge alluvial fan in Death Valley. And this is something I've talked about before. These are tributaries. And here are the major tributaries in Arizona. I love this old map. Again, the Little Colorado and Colorado Drainage Basin and the Gila River Drainage Basin. We also have a little river over here called the Bill Williams River. That's just a pretty picture. I thought I'd throw it in. Braided streams. When water is beginning to slow down, it does this braiding action. You'll see these in washes in Arizona after a flood. And after a flood, you get these weird deposition patterns. I'm trying to rush here so we can get through this. Floods in Cedar Rapids, Iowa. And here's New Orleans. This is what it was like in 2000. Let's get this back. This is what it's like today. This is what it's predicted to be like in 2100. I don't know how to say that, 2100. Here's New Orleans in both cases. Notice all the protective area that we used to have. If we keep this up, we'll be gone. The delta will be out there, but everything else will have been eroded away. Unusual, true. Now when you build a dam, again you end up putting stuff behind it. Not good. We're going to get through this, no worries. Here's an example of a water gap that I had talked about before with the Shenandoah River. Water that's made its way through rising land. Here's a water gap in Victorville, California. And this is at Harper's Ferry. This really is the Shenandoah River coming through here. This cut through these rising ridges. Here you go. You have the river first. The ridges rise very slowly, and the water ends up cutting through it. Just more pretty pictures. Now to calculate gradient, you just have to divide the feet that a river drops divided by the number of miles. If it drops 10 feet in 10 miles, that's 1 foot per mile. I already taught you how to calculate discharge, and let's look at Arizona rivers one more time. Here's the drainage of northern Arizona. This is where the Little Colorado River runs into the Colorado River. When it's not flood season, the Little Colorado River has a lot of salts in it, which make it blue like Havasu Creek. However, normally it is, as John Wesley Powell said, too thin to plow and too thick to drink. This is what it looks like. There it is running into the Colorado River. Now, I don't want you to think that the Colorado River normally looks like this. It's like this only because we have a dam upstream, Glen Canyon Dam at Lake Powell, and that is trapping the sediments, which is why it looks fairly clean. This used to be very muddy coming through here, like this, but we've changed it. Here's a conundrum. How did this happen? A river crossing a river. It's kind of crazy. What happened was way upstream, they diverted a canal and brought it downstream so you could do this kind of thing. Why? I don't know, but it's kind of cool. Here's a summary of what young, mature, and old rivers are like, and you guys can name these. I think that's it. Thanks for listening.